So what we are going to talk about today is these two new features in WireWrite, namely modules and surfaces. So, my gosh, why does it appear with an animation? So, modules are a new feature. They weren't in any of my prototypes before, and they let you scope edges. So, you can scope edges now. So, and we are now able to create these object-like entities that can receive messages and process them, like thanks to modules in particular. And one way to do this is by using multiple transform nodes. So let's just try to do that. Let's try to look at how you can do that. So what we are going to do is we are going to run, my gosh, we're going to run the µsoma app image that you can download on the GitHub page, and here it is. I'm going to remove everything, I'm going to zoom in, let's make it full screen, right? And so one of the ways you can create modules is using a group, right? So you can use a group and create modules this way. So again, as I said in this slideshow there, we can look at, for an example, at an object-like entity. So let's let's say a name here, John Doe, right? Name. And then what we are going to do is we're going to have a transform, right? That is going to take some kind of input, and it's going to flow to some kind of output, right? And what input we're going to take is, let's say we're going to take get name. So just a very standard like object-oriented-ish thingy, right? So a getter, nothing easier to show than a getter. So and what we are going to do is we're going to do with name, and we're going to just return name here, right? And here I'm going to get set name string. We don't need with name anymore. And what we're going to do is we're going to flow this to names, and then we're going to get our name to names, right? And here it also should be as out. And then what we're going to do here is going to use latest to get names to name. And the idea now is that, if we did not use modules, let's use a button here. I'm going to do get name, right? Get name to let's say to messages, and then I'm going to log messages, right? Log messages. And so if I send this now, you can see we get nothing, obviously. So if I send this to in as get name, what we should be seeing is this object thing returning the name, right? Returning the name. Now, and obviously it is returning the name, I'm just not printing it. So you can see it returns John Doe here. But obviously, like if we set name, right, or if we do anything really, this isn't scoped. So this isn't scoped, and we would get like quite a lot of very bad consequences if we, for instance, do two of these objects. Obviously we get two answers now because there are two of these objects, but none of these edges are scoped right now, so it's like global variables, right? And if you want to scope it, all you have to do is you have to expose. So we should do not look at this. Yeah, it's a bug. So basically now we expose nothing, so I cannot communicate with the internals of this group anymore. What we can do is we can go to exposes, and we can expose at in and at out. And now I can communicate with this thing, so you can see it works. And this is a bit weird of an example. Like you can use cover as modules. So for example, I can do cover at name here. So it will show like the name here, and it will hide the code, and we can create a button here. Let's say set name to like Susan Doe, then as set name Susan Doe to in, and then I can click this button. You can see we get the name changed here to Susan Doe, and then we can get name, and it's Susan Doe again. Now this is really not an example of anything, right? So a much better example would be, let's say we have a cell with count, right? And we can have an h1 that shows this count. Now if I create a group with an exposes that is empty, this means that the group does not expose anything. So the moment I capture this count, you can see h1 does not know what to display anymore. So if I move the count in here, or the h1 in here, you can see it now is able to display something. I can move it out, it does not know what to display. So similarly, I can move the cell out, right? So if I move the cell out, the h1 does not know what to display. So if I create another h1 here, you can see this h1 does not work because it cannot reach the cell. And moreover, we can create different cell here, and as you can see, they show different values. And I can use the exposes property to expose the count. So now both of those are going to show. So the count edge is going to leak outside, right? So that's the module part. There's a lot more interesting you can do, but I just don't have like a lot of time to discuss this. So the next topic is surfaces, and for surfaces, so surfaces allow multiple µsoma instances to interact with each other over the network. So this is a very big feature that was missing, and now it is there. So we have sensors and appearances as surfaces. Sensors look for things and appearances show things. So you can have multiple instances of µsoma connected with the network or over the network, right? Exchanging stuff using these sensors and appearances. So you can exchange messages, code, UI, and other stuff using surfaces. Now, they are built with distribution, decentralization in mind, and in quite a peculiar way. So we broke them into atoms, which are just hashes, like 256-bit hashes. So any surface that you see is going to be just a bunch of those hashes, and we sort of distribute those hashes. But right now, I mean, it's quite centralized because I don't have quite a lot of time to dedicate to peer-to-peer functionality. But in the future, again, we hope to only have the network function as a set. So we just have a distributed set. Now, right now, there is no comfy way of getting the thing to run. So what I'm going to do instead is so we need to create a host first. There is no way right now to do this from the UI. So you need to run the app image here with the host TCP command. Then you need to provide some kind of port. I don't remember whether we do the default port or not, but let's just provide a port. So now the server is running at port 9810, so we can now connect to the server. So I'm going to open another terminal here. Terminal, whatever. Please let me open another terminal. So, my gosh, why did it zoom out? So then we can run, two instances of µsoma. Let's run two instances of µsoma. So I'm going to connect using the R flag or remote flag. Then we need to provide the name of the remote. Let's call it remote at TCP 0000 for the local host, and then the port that we have specified here in the server. Then we can run this. And so what this does is it connects to the server behind the scenes, and now we have access to sensors and appearances. Well, we had access to them before, but now we have like even better access, right? Because we can use TCP, so we can talk over the network. So I'm going to create two windows here of µsoma, and we're going to try to connect these two windows together via the TCP server. So these two windows can be located, at the opposite sides of the planet. So we can create a sensor, and let's say this sensor is going to sense a number. And we're going to create this number sensor. Now there's a lot of clipping here, but we will create a number sensor in our remote term space that we have specified here. So you can note that we specify this remote at. So this is the same name that you write here. You can have multiple remotes. The same name that you write here, you should write here in the surfaces. So now I'm going to stream that to some kind of percepts, right? And if we log, so you can see this green light means that we have tried really hard to get this to the server, and it succeeded in some way, right? Due to the algorithm that we are using, we don't really care whether it succeeds or not, truly, but yeah. So this one is going to have a sensor. So a sensor looks for things. In this case, this sensor looks for numbers and captures them under X. So this X here is just a normal pattern. So and what we can do here is we can create an appearance that's going to show a number in the same remote term space, and you can see we get this number here, right? And we can like remove this appearance, and you can see that the sensor is able to see that the appearance is no longer there. And then we can add, another appearance, right? So we can have multiple appearances here. Note that duplicate appearances are considered the same, at least when they come from the same µsoma instance. Now I can do, 1, 2, 3 here, and you can see that this sensor now is able to perceive both of those. We can use the blast node right now to serialize these percepts too, and let's serialize them to, let's say, so there is this second variant you can see with percept, and that's what we are interested in. So let's serialize these two x's, and then we can use percept x, so our little number, right? And then what we can do is we can log x's in here. And what you can do is you can see that now we have this. Now, obviously, this stream is going to be like rather disordered due to some bugs in the implementation right now, and not really bugs, but just like incompleteness in the implementation. But regardless, like you can do this, right? And what we can do now is we can, for instance, display this nicely or something like that, right? So we can create like an h1. So let's do latest at x's at x, and then we can do or cell at x, and we can like show it in the in here. So now there's little point in showing two appearances because we have only one h here, but yeah. So you can see that now we can like edit this thing. So what we can also do, obviously, is we can, let's say, use frag instead. So I'm going to use x string here. So now this appearance is no longer going to be seen like whatever I do here because it's not a string. However, we can do like hello world here, and you can see we see it now. So what I want to do now is I want to have a fragment, let's say fragment cooks. And then what we are going to do is we're going to go changes at cooks to cookses. Then we're going to transform cookses to cookses strings. And we are going to transform that using string underscore. So we're going to transform whatever we have there into a string. So you can look at that very easily. So let's say I get my cursor in there, and it doesn't work. So it doesn't work because I have a typo somewhere. So yeah, this color coding is somewhat useful, right? So now you can see the cursor here as a string. So what this means is what we can now do is we can transform. For now, this has to be done this way, like with two separate transforms. We can transform cooks' strings to appearances, right? Appearance underscore in remote. So we're going to generate these appearances on the fly. What we are going to do then is we're going to do change it or latest at appearances at appearance, and we're going to have a fragment at appearance. And so what is now going to happen, hopefully, is we are going to be able to stream. You can see we can stream whatever we are typing. Moreover, we can type arbitrary programs in there. So I can have a delay here, and you can see that we are able to stream this delay here over the wire. So this is just one small example of what these services are capable of doing. So obviously I will show more, but right now I think that's enough.